Audio issues or anything, please let me know in the chat. Otherwise, I will just launch right into this. It's a pleasure to be with you folks today. My understanding is that you are fairly new to painting. You're in a beginner painting course. So I thought that today we could go over kind of the dimensions of color and how to navigate them, especially in terms of paint mixing, right? And so we'll try to keep it practical and related to what are some of the key things you want to watch out for as somebody just learning to navigate making colors, matching colors, finding your way in colors with paint. Once we get through the material I'd like to present to you, we'll do some Q&A over Zoom. We'll switch over to that platform so we can interact more directly. And in the meantime, if you would like to mix along with me, we'll be doing some very basic mixing exercises just to kind of illustrate some of the things that we'll go over today. All right, so here's where I want to start. I want to start by defining three key terms that artists and color scientists use. So you're probably aware at this point in your career as artists who are learning the craft of the difference, for example, between the intensity of a color and the lightness of a color and the hue of a color. But I think the definitions that I want to go over with you really quick at the outset are definitions that are developed by the CIE, which is a scientific body of experts that goes back almost 100 years, who have kind of tasked themselves with trying to define with as precise language as possible some of these terms related to color and light and what we perceive visually. So the CIE, that's a French acronym, Commission of International CIE, Éclairage, which is light. So basically the International Light Commission, and they've been around since I believe the 1920s or 30s. And here is how they define the three key terms we'll talk about today: hue, chroma, and lightness. So hue, H-U-E, is, in CIE language, how similar we perceive a color to be to red, yellow, blue, or green, which is a very interesting definition. How similar do we perceive a color to be to red, yellow, blue, or green? So you're kind of defining color in terms of color, which sounds a little circular, but there's a reason for that. Red, yellow, blue, and green are kind of the north, south, east, west of the CIE's color spaces. And so let me show you really quick what I mean by that. So right here, I'm going to talk about what these little dots are in a second, but if you think of this like a clock, right? 12 o'clock straight up and down in CIE's way of defining color is yellow, right? Like perfect yellow, basically. 3 o'clock is red, but it's a red that leans a little bit toward magenta. 6 o'clock straight down is blue, but it's a blue that's more like indigo. It's a blue-violet. And then 9 o'clock is a green that leans a little bit toward blue, right? A sea green, let's say. Okay, so yellow, red, green, blue are the 4 points of the compass in the way that the CIE measures color. So that's why they define hue as how similar is a color to one of those 4 directions, basically, okay? You could add in a fifth, and sometimes I do, and I say that hue is how similar a color is to red, green, yellow, blue, or purple, because in Munsell's color system, purple is considered a fifth distinct hue perception that we don't think of as, you know, blue with red or red with blue, so that's kind of debatable. But anyway, that's hue. Another way to think of it is what o'clock is it, right? What angle around this circle are we talking about? And that's hue. Okay. The second one, chroma. I think a lot of people mix up chroma and saturation and intensity. These are all slightly different terms, but they're all referring to how intense a color is. But here's how I want to define chroma with you. Chroma is how different a color is from a shade of gray that's the same lightness as that color. Okay, so how different is, say, a green from a shade of gray that's the same level of lightness as that green. That's how you can measure chroma. If it's not very different, if it's very close to a shade of gray, it's called a low chroma color. And if it is very different as possible, a very vivid, intense green, then it's considered a high chroma color. And so if you're looking at this chart here, the center of the circle where that little dash is like 0 chroma. That means that's white, black, gray. Those are all the shades of gray. They have no distinct hue. They're right in the center. And the further away any of those dots are, that means the higher in chroma they are. The closer they are to the center, the lower in chroma they are. So it's just a measure of how intense they are. The last thing to mention in terms of defining chroma, or the intensity of a color, is that it is measured, chroma is measured as a proportion of the available light. So kind of what that means is if the lights are down really low and you're looking at an object that you perceive to be red, that might not be, if you compare it to a red under a bright light, it might not be very colorful, but it's as colorful as it can be under that lighting condition. So chroma is actually measured as a proportion, like how much percent of light is being reflected back by that red or green based on how much light is available. And that's going to be important later when we talk about shading a color. All right, the last element is lightness. I think a lot of traditionally artists will say value, but value is kind of not considered the scientific term. It means basically the same thing. It means how much light am I perceiving to be reflected off of something or shining from something. So lightness is the perceived total amount of light being reflected by a color. Okay, so the key word there is perceived, because it's not literally how much light is being reflected. It's how light we perceive it to be, and there's a difference there. And if you think about how your camera, for example, might on your phone, your digital camera might have white balance, right, where you can adjust the level of lightness. Like right now, my camera here that I'm using, this side of my face is kind of washed out here because it's having trouble balancing the light. Is this side of my face actually white? No, it's just that the perceived lightness that the camera is perceiving is maxed out, right? So perceived lightness is not the same thing as how much literal light is there, but once your eyes adjust and how much you're perceiving. And that's important too. So all of these terms are defined in terms of perception. Hue is what color do we perceive it to be compared to yellow or green or whatever. Chroma is how intense do we perceive it to be if we compare it to gray. And lightness is how bright do we perceive it to be under the given conditions of lighting. Okay, because all color is perception. Okay, so we've got these 3 dimensions, and the question is kind of how they all work together. So I want to just show you a couple models really quickly. I think a cylinder model, if you could imagine this is kind of all, here, let me go in front of the camera here. If this is solid, right, it's got a circle on top and a circle on bottom, and imagine it's all filled in solid, and really we're just seeing a slice, right? It's black at the bottom. As you go up, it gets lighter and lighter until it gets to white. So one dimension of color, if color is like a 3-dimensional thing, is lightness. And then another dimension is chroma. If you go from the center, which is gray, further and further away till the edge, which is the most color you can have, that's chroma. And then the third dimension is hue. And in this situation, that would be kind of measured as what angle am I around the circle, okay? Something you might notice about the model I've built here is that the center color circle is slanted, right? And we're going to talk a little bit about this later, more in depth, but the idea is that actually some colors at their fullest intensity or chroma are actually higher in value, closer to white, than others, right? This blue-violet down here, sorry, it's like backwards, messing with my brain. It's like a drunk driving test here. So here we go. So this blue-violet down here is closer to black. It's lower in lightness at its fullest saturation, and this yellow is closer to white. So that's why this wheel is slanted in the middle. Okay, so if you can think about color as this 3-dimensional space that you're trying to navigate when you're mixing paints, that's like step 1. And then step 2 is to realize that color is just an idea, but paints are physical reality. And pigments that are in a medium, like this cadmium red acrylic paint, right? It's got its own quirks as a substance, and it's not always going to behave the way we think it would in an ideal kind of color conception. And so that's a lot of what we'll focus on today, is what are some like key things to be aware of and to know about when it comes to mixing paints, and how they kind of don't follow the ideal in terms of color. Okay, so let's begin by talking about hue spacing. All right, so most of you are probably familiar with this color wheel or something like it. I'm going to switch my camera here. This is the bane of my existence. I don't know if you're familiar with my work on TikTok, but a lot of what I do on TikTok is talk about how this kind of popular conception of the color wheel is flawed in a number of ways. It's supposed to help you mix paints and predict what's going to happen. It can't really do that effectively, and it's also supposed to help you come up with color harmonies, and it also kind of doesn't do that very well. But we're going to look at it a little bit scientifically right now. And what I want you to think about is first what this tries to assume. Number one, it tries to assume that the hues of red, yellow, and blue, it tries to assume that they're evenly spaced, right? There's the same amount of space between all three. What does that mean? That means this wheel is assuming that the number of steps it takes to get from red to yellow is roughly the same as the number of steps it takes to get from yellow to blue, and that's roughly the same number of steps it takes to get from blue to red, right? They're all equally spaced. And this is just not true, and so let me show you this diagram again and try to explain what I mean. All right, so this is, I took a digital photo of this color wheel, and I sampled each of these 12 hues around the circle, and I put those samples in this program. This program is called the Artist's Helper. It's free. It's available as a free download online. You can find it at theartistshelper.com. And what it does is it allows you to put color information from a digital picture into a color space. And so the color space I have on the screen right now is a color space developed by the CIE, which I talked about before, this kind of scientific community. And they developed it in 1976 to try to create a model where all the distances between colors, right, the steps it takes to get from red to yellow, for example, are perceptually uniform. Meaning if I am trying to judge how far apart is this green from this blue or this purple from this red, and I kind of divide it into the smallest divisions of what I can tell the difference between, this color space is supposed to model that and show truly how far apart these colors are. So if you take a look at these 12 colors that this wheel is saying are spaced evenly apart, you can see that the science is disagreeing, right? The yellow up top, if we just look at yellow to yellow-orange to orange to red-orange to red, you can see a couple things. The red and the red-orange are right on top of each other. They're very close. They're almost not different at all. And you can see that the spaces between orange, yellow-orange, and yellow are kind of evenly distanced apart. But shouldn't the orange be actually right in the middle rather than kind of like 2/3 of the way to red? The other thing you might notice is those greens, everything between yellow and blue. You've got kind of the middle green, which is a little bit on the yellow side. And then you've got yellow-green, which is way closer to that green than it is to yellow. And then if you look at the bottom, take a look at blue, blue-violet, and violet. They're all actually almost the same angle. They're all like 6 o'clock. If 6 o'clock is straight down, they're all kind of like 6:30, right? Give or take. So they're all actually just different lightnesses or intensities of almost the same hue. So this color wheel is having trouble actually just even representing evenly spaced colors, and so therefore it makes a pretty bad map if you're trying to navigate the distance between colors. The other thing you might notice, and we'll talk about this a little bit more in depth later, is that all of these dots are different distances from the center, right? Which means that even though this wheel is trying to say here's kind of the brightest each color can be, it's limited by what can be printed on a CMYK printing press, and so some of those colors are actually duller than other colors. especially that violet there, which is quite close to the center. Okay, so what's the point of all this? Again, if you're trying to navigate the color space with a map that's not accurate, I think you're going to get a little bit more lost or confused, or you're going to start assuming that you're making mistakes. You're going to say, how come the green I tried to mix isn't landing where it's supposed to mix? According to the color wheel, which is telling me, you know, if I mix this and this, I'm supposed to get this, right? You're going to get frustrated. And I've seen many beginning artists express that frustration. All right. So what do we do? Well, number one, we can say, okay, actually, let's see where my actual paints are rather than just looking at the idea of each color. So let's go back over to my my palette here. Okay, so I tried to get the same paints that you guys are working with. So this is Golden's primary yellow. This yellow is a mixture of benzimida yellow, Hansa yellow, and a little bit of titanium white to give us kind of a neither cool nor warm, like middle of the road yellow. And then this is cadmium red. We've got cobalt blue. We've got our warm neutral raw umber. Sorry if my camera kind of goes in and out of focus. And I've got Mars black, which is a slightly warm black, right? Whereas an ivory black is slightly on the cool side, usually. And then titanium white. I didn't get Golden's titanium white, so this is like a cheapo one, but it'll serve our purposes today. So first, let's just take a look at what these look like. And then, again, if you're kind of playing around with paints as we go, I encourage you to do so. We'll do some basic mixing. I encourage you to mix along. So I'm going to just put a little dab of yellow here. I'm going to put a little dab of red over here. Just going to do that. Boink. Okay, that's a nice bright red under this light, isn't it? And then a little bit of cobalt blue. Pardon me. I think I need to wet my whistle. So again, if you're mixing along, let's get a little dab of each of these out on your palette. And the first thing we want to say is, where are they really in relationship to each other? Are they actually 120 degrees apart? Or are they evenly spaced in the color space? And the answer is not really. I'm going to pull up my diagram here. I took a photo of these same 3 swatches earlier today, and here it is put into that CIE color space. And you can see the yellow, even though it's supposed to be a primary yellow, meaning it's not really leaning warm or cool, it is slightly leaning warm according to CIE standards. The red, cadmium red, is slightly leaning toward yellow. And then the cobalt blue, interestingly, is actually a lot closer to the middle than you might think, right? So everything's leaning over to one side. The red and yellow are a lot closer together than you think, and the yellow and blue are a lot further apart than you might think. So what does this mean? If I'm trying to learn to navigate color mixing, what this is telling me is that if I want to mix an orange, the road that I have to travel is a lot shorter. That means that I'm going to see a lot of small changes in hue with a very little bit of different amounts of paint, whereas the road I have to travel to get to a green is like way longer than you'd think it would be. There's all these shades of like cyan, turquoise, green, yellow, green. There's a whole half of the color space between blue and green that I have to navigate. Okay, so let's do a little bit of mixing to kind of start experiencing this. I'm going to first mix a little bit of an orange. What I'm going to try to do, and I invite you to do this with me, is try to land right in between what I think, according to my perception, is perfectly between red and yellow. Okay, so I am going to start with a little bit more yellow and a little bit less red. Why? Because the red paint is a little more strong in terms of its tinting strength. And if you went 50-50, right, 50% cadmium red and 50% this yellow, you would end up closer to red, I think, because it's a stronger pigment in terms of its tinting strength. All right, so that, I'm actually feeling like that's a little too red still, so I'm going to put a little more yellow in. Okay, By the way, I don't know what you guys are mixing with. I'm kind of curious. Maybe we can talk about that in the Q&A. I've been mixing with a knife for years, but when I was in school, most of my mixing was with a brush on the palette, and it wasn't until I think my my third or fourth year, probably in college, that I really started to learn how to mix with a palette knife. So I'm putting a little bit more yellow into this mixture, and it's feeling a little bit more like that medium right between orange, right? So a tiny bit of yellow really affected that balance. And again, what I'd like you to take away from that is that the road I have to travel, the distance between red and yellow, is really a lot smaller than you might think. This cadmium red especially. So I, as an artist, don't typically work with cadmium red. I prefer reds that are a little further, what some people call cooler. I like pyrrole red, which is a little bit cooler. I like quinacridone red, which is a lot cooler. And of course I like quinacridone magenta, which is halfway to fuchsia almost, right? It's got a lot of purpliness to it, and it mixes really nicely. So to me, this red here, this cadmium red, is almost like a scarlet. It's almost more of an orangey red to me. So again, I see these colors and the distance you have to travel to get between them as quite small compared to the distance you have to travel to find green, right, if you're aiming for a specific green. So to get a specific hue of green, I think that this is like a problem for a lot of people, and it's a reason we have convenience mixtures. There's actually no pigment for green that's like in the yellowish green area. All of the things that you could buy, like permanent green light, those are mixtures of phthalo green and hansa yellow, or two existing pigments that are further apart. The reason like we don't have green pigments, like it's like they haven't been discovered yet, but there's also kind of no great motivation or impetus to discover them because we can get pretty high chroma mixtures of green from the pigments that we have. So here's what I want to do actually. I think to really get a sense of how the space between blue and green, right, all this space on that left side of that diagram, that's like uncharted territory, there's like what's in there, right? I think we need to mix some different proportions just to kind of see how this road gets traveled, because it's not linear. There's not a one-to-one relationship between how much paint I put in and how much the color will change. And that should be a big takeaway for you today. So here's what we'll do actually. I'm going to go back to my palette. Come with me. And I'm going to measure out in blobs. I'm just going to kind of kiss the palette with my paint tube here. I'm going to do a 1-to-1. So there's a little witch hat, as my daughter would call it, a little Hershey's Kiss of blue there. I'm going to make a 50-50 mix with yellow. I'm going to make a, let's go like 2-to-1, so 2/3 blue and then 1/3 yellow. And then we'll go the other way, where we'll do 2/3 yellow and 1/3 blue. Okay? So I'm just setting up my blue dots here, and then I'll set up some yellow. Now I couldn't get the tube of yellow, so I'm going to have to eyeball it, and my proportions might be slightly off, but you know, we'll get the basic idea down. All right, so here's my 2/3 blue, 1/3 yellow, approximately. I'm going to pull some of that back up and just try to get close to a 2-to-1 ratio. Now we'll do a 1-to-1. So my middle one will be about 50%, roughly 50% yellow, 50% cobalt blue. And then this guy's going to be 2 splodges of yellow. That one's probably too big. And here comes another one. Okay. And you may have done some exercises like this before, but hopefully putting it in the context of, you know, how long of a road am I traveling through color space really, which is quite different from what you might assume if you're just looking at a traditional color wheel, right? All right, so let's mix these together here. So I'm going to make my 2/3 blue, and if you're doing this along with me, take a look at what happens and notice closely what happens as the pigments integrate. I'm seeing in this first one what really looks like, I don't know, it's a forest green maybe. It's almost a teal, not quite. Almost teal. Almost like a desaturated cyan, but not quite enough blue in it. Right? So at the very least we'll say it is certainly leaning blue. Okay. Now let's go to the middle one. I might have to space these out a little better so I can mix them here. So this is supposed to be 50-50, this guy. If you're mixing along with me, take a look at what's happening. And the question here is, how different is the color from the other one we just mixed? All right, I'm trying to mix kind of fast and loose. I encourage you to do that as well when you're just experimenting. It's easy to kind of be a perfectionist and try to be neat. I'm always telling my students to get messy and make mistakes, like Miss Frizzle. Get messy, make mistakes. So here we go. So this is 2/3 blue, and this is 50% blue. I don't know how it looks on camera to you, but to my eye, they're somewhat close. Right? They kind of look like just slight variations of each other, not a huge difference. Now let's see what happens with 2/3 yellow over here. Okay, I'm going to mix this guy over here. And immediately I'm seeing that this guy is going to be quite different. Okay. Wow, what a difference. Okay, so I'm curious what your results were, but I'm going to describe my results as I see them. So even though I know that this is 66% cobalt blue and this is 50% roughly cobalt blue, right? Those two look a lot closer together in hue than these two, right? Even though the change in proportion is about the same. This is 66% yellow and this is 50% yellow, right? So what does that mean? That means somewhere between these two proportions, I'm kind of turning a corner, right? And so it's not linear. So you would expect, if I were to throw these into this modeling software, right, you would expect that maybe those 3 shades of green I just made will kind of be like, let me go backwards here. It would kind of be like dunk, dunk, dunk. They should kind of be evenly spaced. But I think based on what these swatches look like, that 2 of them would be very close together and the other would be a lot further up close to yellow. And so what does that mean? That means that actually the proportion of paint as it changes the hue in a non-proportional way, right? So there isn't a one-to-one relationship. I'm not moving the perceived color by X amount by putting in X amount more yellow. It's actually like whoop, it's actually kind of like curving or sliding scale. Okay? And that's very important to know if you're trying to match a shade of green. All right. I'm going to take a minute to just clean up my palette here and get ready to transition here. So I think there's kind of a couple key takeaways for this section of the talk. And we're just focused on hue, right? Just the dimension of color that is hue. Number 1, the tinting strength of pigments are not all equal, right? Blues tend to be much stronger. They're almost like concentrated, right? Reds tend to be pretty strong, and then yellows tend to be quite weak. They're easily overpowered in terms of how much influence they have on the hue. So every pigment, every type of colorant has its own specific amount of strength when it comes to how it influences a mix, and that's called its tinting strength. So part of learning to mix colors is learning the different tinting strengths of things, and kind of just a good place to start is like yellow is weak, you always need more than you think. And then the other key takeaway here is that the traditional color wheel is actually not spacing things very accurately. And so if you'd like a more accurately spaced color wheel, you're welcome to download mine for free. This is available on my Linktree, which you can find by just Googling Color Nerd Linktree. And this is based on the CIE, so we've got yellow and blue-violet opposite each other, and we've got kind of magenta and sea green opposite each other, so those are those axes that I talked about. And the color differences are based on CIE, science in terms of how we perceive color differences. This chart also has all the different pigments, not all of them, but maybe about 50 pigments, different artist pigments charted so you kind of see where they are. Okay. So again, you're welcome to download that for free if you are interested in that resource, and if you're interested in kind of increasing your knowledge of where specific pigments are, and getting out of the mental habit of thinking of paints as colors, right? Colors are just ideas. Paints are physical substances that all have their own quirks and qualities. All right, so we've talked about hue. Now we're going to shift gears and talk about chroma. I'm trying to clean up my palette quickly here, and try not to breathe any of these cadmium particles that I'm creating by scraping my palette, or cobalt particles for that matter. I'm just vamping as I finish cleaning, but if you haven't talked about pigment safety, cobalts and cadmiums are among the more toxic pigments, and you want to just be careful that you don't accidentally eat or inhale. All right. Beautiful. Let's move on. Good. So we're going to talk now about the second dimension, chroma. Chroma, the intensity of colors. So remember again that chroma is how different a color is from a gray at the same lightness. But to get a better grasp of it, I want to talk about the difference between relative chroma and absolute chroma. So the traditional color wheel is just two-dimensional, and there are three-dimensional models out there that you can get. This one I actually quite like. But a lot of these, if they reduce it to a sphere, or even my idea of a cylinder, is actually kind of not 100% accurate, and here's why. This is telling us, okay, the closer to the center you are, if you go into the sphere, the closer to gray it is, the lower the chroma. But because it's a perfect circle, it's saying that the maximum chroma of every color is like the same. They're all 100%. They're all like equally maximum at the edge of this circle. And that's not true, right? Because different colors actually have different maximum chromas. And it just seems to be the case that warmer colors, for example, tend to have more chroma than cooler colors. Maybe it's because of the structure of how the human eye works. There's a lot of complicated science behind it. But the idea is that, the paints that you have actually reach their maximum chroma at different levels. So if I go back to my chart of our primaries, the ones you guys are working with, right? These are actual samples of the paints we're working with here. The cadmium red, the primary yellow, and the cobalt blue. This is where they end up in terms of chroma, how far each one is from the center of the color space. So if you look at those, the question is, which of your paints has the highest absolute chroma? The answer should be obvious. It's red, right? It's outside that circle, whatever that circle represents, whatever measure. The yellow is a little bit lower. It's just inside the circle. And then the blue is even lower. So even though that's a pretty bright blue, cobalt blue, the absolute chroma that it has is lower than the absolute chroma of yellow and red. And that's important to know, because again, if you're just conceiving of these as colors and they're all equally bright, you're not realizing that the distance to navigate between these things might be different. Okay? All right, so we want to mix something else here. We've done an orange, we've done some greens. Let's do a purple, because I want you to see something that happens with paint mixing, right? All of these primaries, the reasons people call them primaries is because they're pretty high in chroma, and you can mix a good range of colors from them, right? But the colors that you can get from the given primaries that you have can be different. So let me switch back over. If you are mixing along with me, grab your red and your blue, cadmium red and your cobalt blue. We're going to make a purple here. Okay, the orange we got was pretty good, right? And the greens we got, I mean, the ones that were closer to blue felt a little duller to me. I don't know if they felt that way to you, but the yellowish greens that we got were pretty good too. Let's see how this purple looks if we're mixing cobalt blue and cadmium red. All right, I'm going to start by actually a fair amount of blue with just a little dab of red in it. See how that does. Okay, if you're mixing along with me, pay attention to what happens. What's interesting to me is because these are both pretty punchy colors, at first when all the colors kind of swirl together, it can look pretty vivid and kind of exciting. But then as you integrate them, this purple that we end up with, I mean, it's definitely a purple. This one's leaning a little red. I'm actually going to add a little more blue to really get to a true like violet, like in between red and blue. And as I add a little bit more blue, I mean, it seems to darken a little bit. It seems to get a little duller, right? This purple is, I mean, it's okay, right? It doesn't really compare, to me, it doesn't really compare to the yellow greens and the oranges we can get from these primaries, and it certainly doesn't compare to the brightness of that red, right? So let's take a look at our secondaries, our so-called secondary colors. I'll go back over to my diagram and actually move to the next one here. So I mixed up all of these samples earlier today. This is what I mixed up earlier today. I mixed my green, my orange, and my purple over here. So I'm getting mixed up again. So that's my purple, and it's actually quite dark now that it's dried, and you may find that as well. Your purple looks okay until it dries, especially in acrylic. It seems to darken as it dries. But if you look at this chart here, again, this is just a photo of those 6 colors that I made on my palette, and it's charting them in terms of their hue and their chroma. So the green, you can see, is kind of dull. It's at like 30%, right? The orange is pretty good. The orange is like on a line right between the red and the yellow. I tried to get it right in the middle, but it is leaning a little toward red. Not too bad. But then look at that purple. That purple is so dark and dull that it almost is touching the center point. It's like almost gray. It's almost a dark gray. Part of that is due to the camera, right? RGB cameras, digital cameras, are actually not really that good at picking up shades of violet. Just because they're white balanced like in a certain way to try and like get interior lighting right, and interior lighting does not do any favors to purple. So that's part of it. But this is accurate that the purples that you can get from mixing cobalt blue and cadmium red are very low chroma purples, right? So I mean, you do get a range of colors from these primaries. You don't get as wide of a range of colors as you would if you were using other primaries, and maybe, you know, in your second year or third year painting, you'll get into that a bit. But I think it's worth knowing at this point that it's not you, right? If your purples are very dark and dull that you're mixing from this palette, it's not because you did something wrong. It's just because that's how those pigments behave, and I think that's worth knowing. One thing I will say, you can get a little more color out of it sometimes if you add white in to your purples. And the other thing I will say is that a lot of people will actually end up leaning their purple more red to get a little bit more brightness back into it. I can do that real quick to show you what I mean. Like this I'm aiming for like a true violet right between red and blue. But I think most people find that too dark, and so they end up putting more red into their purples, and they end up with these very almost like a dark magenta-y kind of color and calling that purple. But it really should be considered like a magenta. So anyway, that's one way people cope with it. Another way is to add a little white in, but then of course it becomes more pastel. All right, so chroma can do funny things. And I think the takeaway from this is that when you mix 2 bright colors together, the resulting color isn't going to be bright necessarily, right? And the further apart your colors are, like for example my yellow and blue are almost opposite each other in this CIE color space, I can get a green out of it. See how that kind of like nudges to the side? It doesn't go gray. But it's going to be a dull green, right? That's like a green at 30% chroma rather than 50 or 70 or something like that. So what's interesting here, and kind of the takeaway here, is that your secondary colors, your intermediate colors that you can mix, there's kind of a cost, right? They're going to be duller than if you had bought an orange, straight out of the tube and all that kind of stuff. And again, once you get on in your career, if you want to expand your palette and buy more colors, that's why people do that, right? And you can say, well, I want some cobalt violet light. It's $60 for a tube this big, but I just want it on my palette because it's such a beautiful, punchy, bright magenta. But that's not something that makes sense as a beginner. Okay, so our secondary colors are duller than the colors we started with. But does mixing always make it duller? I want to show you a weird kind of side note here. For cool colors, this only tends to be true for cool colors, like blue greens, purples, even cool reds like magenta. If you mix a little bit of white in, you can actually gain chroma. You can actually end up with a color that is more intense. So if you've got your cobalt blue handy and you've got some titanium white, I want you to try this with me. Don't do a lot, just a little touch of yellow. It's going to do two things to your blue. If I just grab a little tiny bit of this yellow and I mix it into this wad of cobalt blue, it's not going to change it too much in terms of the color, right, overall. But it is actually still going to look pretty punchy. Right, that's a lighter blue, but it's also actually a slightly more chromatic blue. It's a slightly more punchy, intense blue. How do I know this? Well, there's this whole theory called Kubelka-Munck theory that tries to mathematically model the way pigments interact by looking at their spectral profiles, blah, blah, blah. There's like a lot of science behind it. And all the models predict the same thing, that cool colors, when you add a little bit of white, it actually increases their chroma. So I mixed this earlier today. If we go back to this here. This blue, this is just pure cobalt blue. This is with a little bit of white, like I mixed just now, and this is with a little bit more white. And I measured these with this same program. I'm going to flip over to the next image here, and you can see the cobalt blue by itself is the darker one that's closer to the center, and then the two other ones where I added white and then more white are actually a little further out, closer to the edge of that circle, meaning a little bit higher in chroma. So that's worth knowing too, if you're just a beginning painter, that if you need a little bit more chroma, a little bit more punch out of your cool pigments, you can sneak a little bit of white in and you can get there. This doesn't work, by the way, for like red, orange, yellow, because warm colors tend to already be at their maximum chroma. So adding white just will make them more pastel. It will just actually desaturate them a little bit. All right. So let's sum that up. That's the end of kind of section 2 here. And I'm going to do section 3 probably pretty quickly because I want to save time for Q&A. The takeaways from section 2, let me go back to this camera, sorry, are every pigment has its own maximum chroma, right? There's different amounts of maximum. Reds tend to have the most chroma, reds and oranges, and blues and greens tend to be lower in chroma. And so that can affect the way you navigate mixing those. Mixing two colors will almost always lower the chroma, right? Like our green, orange, and purple all had slightly lower chroma than the red, yellow, and blue. Except sometimes adding a little bit of white can increase chroma slightly. And there are some weird exceptions where yellow greens will actually have slightly more chroma than the yellow and green you mixed it from. But again, that's only if you're using like phthalo green and specific yellows and stuff, so you probably won't encounter that. All right, so let's move on to lightness. We talked about hue, we talked about chroma. Let's talk about lightness real quick. So if you look at the primaries you have, the red, yellow, and blue that you have, can you say which of those is the lightest, which has the highest lightness, or which is closest to white? I think most people can probably say that that's yellow, right? Yellow is a very bright color that it actually reflects most of the spectrum, and that's why it's so bright. The only wavelengths it's absorbing are are the blue wavelengths at the end of the spectrum. It's reflecting everything else. That's why it's so bright. But it gets a little more tricky to kind of say, well, which, is this blue or is this red higher in value? Because we get confused by its intensity, right? You might say, well, that red is probably higher in value, but we're actually just looking at how chromatic it is. So I want to introduce you to a tool that can be helpful for you. It's called the value wheel. It's not really a wheel at all, but that's what the creator decided to call it. Let me zoom in on this for you a little bit. So Bruce McAvoy, he's got this amazing website called handprint.com. It's got so much information on it, like it'll take you 5 years to read everything on the website. But if you just Google Artist's Value Wheel, you can find this. It's a PDF you can download. And he shows basically all these pigments, artist pigments that people use, and what level of lightness they all are. So if I zoom in actually a little bit more, if I can figure out how to do that here. There we go. You can see that yellows, if I scroll up, are all close to white. Titanium white isn't 100%, right? It's like 96, right? There's no perfectly white paint. But PY175, which is one of the pigments in your primary yellow, is up there. It's at like 90. Okay, so that's a very high value. So then the question is, well, how do I know like where my reds are and stuff? And again, I can't really do that by eye very well. So I rely on resources like this when I'm trying to sort out which paint has the higher value or what level of gray should I mix to match this. So cadmium red is here, and then if I scroll over, you'll see that actually raw umber and cobalt blue are all around the same level. They're all at around 45, whatever that means. It just means that they're all slightly below middle gray in terms of their value level. Okay. So what does that mean? Well, for the most part, when you're mixing two paints together, it's going to be averaging the value, right? It's the value of the resulting color is going to be pretty much between the two that you started with, for the most part. But it gets a little funky when you're mixing colors that are very far apart from each other on the color wheel. So if you're going across like orange to blue, you might get a gray, but you might also get something closer to black. And it all depends on whether or not the blue is reflecting any red light or not. So it gets funky, but that's one of the reasons why when you mix your cobalt and your cadmium, you get this purple that often comes off very dark, because you're mixing two colors from opposite ends of the spectrum, blue and red, and rather than meeting in the middle, they're kind of canceling each other out. Okay, so I think the last thing I want to cover real quick, and then we'll do Q&A, is when you are trying to shade a color. I think a lot of people get this advice: don't use black. Don't shade a color with black, because when you mix black paint in, it dulls the color down. And that is true. But most people also give this advice, which is kind of co-opted from the Impressionist movement from like over 100 years ago. If you're trying to shade a color, rather than using black, shade it with its complement. To me, that's very problematic, because the problem that we're trying to solve is that when you mix black with a color, here's what it does. It lowers the chroma faster than it lowers the lightness. And if you're mixing a complement, you're lowering the chroma, because two opposite colors are going to kind of go to gray in the middle. So I want to show you a couple of things real quick. I shaded a pink. I mixed cadmium red with some white and made this pink color. On the right, I shaded it with black. You can see how it gets kind of grayed out in the middle, right? It's like bleh, it's a little muddy in the middle. On the left, I shaded it by first adding in a little bit more red and then adding in a little bit more black, right? And so you end up with what looks a little bit more realistic in terms of how light behaves, in terms of how light shades things from a light source. Because if you remember our definition of chroma, it's a proportion, it's measured as a proportion of the available light. So as light goes down, as you're shading, like if something is in shadow that you're trying to paint, as light goes down, the chroma should not go down faster than the light is going down. It should stay proportionate. So what I actually did was I took this image and I put it in my program here. This is the one on the right. where I just added black, you can see it's going toward the middle, and if you don't know how to read this chart, up and down is value. So black is at the bottom, and then that line in the middle is like 50%. So my pink is just under 50% in value. It's kind of a dark pink, I guess. But then you can see as I'm shading it, it's kind of curving in. It's going toward gray before it goes down toward black. So that means if I shade with black, I'm gonna gray it out. And that's not how shading actually works in real life. The second one goes more in like a straight line. And this is the one where I added back red before adding black, right? And what this does is it brings back chroma before we kind of darken it down to black. Okay, so I think, you know, this is just kind of my public service announcement that if you're receiving the advice, that you should be shading with the complement, know that that's somewhat problematic, especially if you're trying to render shadow realistically, right? Like Monet could do it. He made like purple and blue shadows, and like it was cool, and it was like an emphasis of simultaneous contrast, and there's a lot of stuff going on there. So I'm not saying it's wrong. I'm just saying it's not the solution to the problem of the fact that when you add black to a color, it loses chroma. You can shade with black as long as you put in the chroma that you're losing. Okay, so I'm going to close there. I do have kind of a summary slide. If I, here we go. Throw this up here. This is something I can send Candace to you, and you know, you can have as a resource for sure. But this is just kind of a summary of everything we talked about. This is one of the reasons I wanted to do this on YouTube, is it will then record it, and the same link that you used to go to this live stream will, once the video is processed, play the replay. So anybody in the class, if you would like to rewatch any portion of this, it will be available via the same link as a replay, and you're welcome to watch that at any time. All right, so I'm going to stop the stream now and head over to Zoom, and I will see you there.